Guys, it's a parent function, right? And what do I mean by parent function? It's one of the ones that didn't get shifted at all. It's just sitting in its original position, okay? So would we all agree that this is the parent function of y equals x squared? A parabola that's sitting at the origin as its vertex, right? Blake, what happens when I add 1 to x squared plus to x squared? What is this parabola going to do? It's going to shift up 1 unit, right? Blake, what happens if I were to subtract 1? It would shift down 1 unit, okay? Blake, when I shift this up 1 unit, so actually let's take what Blake said. How is the graph shifted? Going to shift up 1 unit. So f of x will be x squared shifted up 1 unit. All right, so create a quick sketch. So Blake said it's going to look like this guy. Shifted up 1 unit. Cool? What can you say? Really simple question. What can you say about this green graph? Does it have any x-intercepts? I see, at first I saw yes, then I saw no. What's an x-intercept? Roots, right? Yeah, so does this green graph cross the x-axis at all? Yeah, no roots, right? No roots. So f of x has no roots because it never crosses the x-axis. Algebraically show that these intercepts do not exist. Guys, how do I find roots? Take a quadratic and set it equal to 0. Of course, yeah. So if I take x squared plus 1 and I set it equal to 0, and I told you guys I need to find roots. I need to find roots. So it's equal to 0, correct? So what are my options now? I can factor it. I can complete the square. I can use the quadratic formula. I can use polyroots. I can graph it and see where it crosses the x-axis. Well, didn't I just do that up here? And we already know there are no answers. Okay, so what would happen if I tried polyrooting this? What would be my A term? 1. This is a tricky one. What's my B term? 0. Yeah, there are no x's, right? There are no x terms. So this is 0. And my C term would be a 1, right? So if I use polyroots to try to do this, let's see what happens. Menu, algebra, polyroots, 101. All right, polyroots, x squared plus 1, x, good, it's all set up, and I get that. What is that? It's an empty set, which means there's no solution. Yeah, so polyroots, so if I did polyroots, it gives me that. I can't draw those, you guys know that, right? Can't draw squiggly brackets. So those are squiggly brackets. No answer, no solution. So this means no. This means no solution. All right, so what if I said, okay, well, that seems odd. We haven't seen that happen before, right? So then what do we have? We have negative b. We have b squared minus 4ac. We have 2a. So let's just see what happens when we use the what? The quadratic formula, right? Let's see what happens, because you guys are pros at using the quadratic formula. So I have 1, 0, 1. Let's do it. 1, 0, 1. And I get all my terms. So I have a negative b. I have a b squared minus 4ac. And I have a 2a. Well, this is weird because the formula gave me answers, right? So I got a 0, a negative 4, and a 2. All right, let's put those in the proper spots, right? So this was 0. This was negative 4. This was 2. So we put them in the proper spots, and we get this. And the math student has been paying really, really great attention this unit, looks at that and says, uh-oh, Mr. Ricardo, I see something that you've been saying we can't do, and what is that? Yeah, this square root, right? This, we can't have a negative square root. Right? And why can't we have a negative square root? Because I told you guys that the way to take a square root is to get two numbers that are the same that give you the thing under the radical, right? And there's no way I can have two numbers that are the same that multiply to give me a negative 4. So we have a problem, okay? Everybody good so far? All right, so we understand that right now we got a problem, okay? By the way, down below it said using the square root method, okay? This is a weird circumstance, guys, where if you wanted to solve this, if it's just x squared plus 1, can I just subtract 1? That gives me x squared equals negative 1. And then I take the square root of both sides, but here we recognize that what? There is no solution because I can't take the square root of a negative 1, right? Okay, so that's the square root method, right? Guys, the only time you can ever use the square root method, Caesar, is if what? Is if you have an x squared and you just have a regular number. There can be no x term. Otherwise, the square root method won't work, okay? All right, so here's where I'm going to make your life really, 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 really easy. Okay? When I tell you guys that there is no solution, there is no solution in the only number system that you know. And what number system is that? Whole numbers fall under what? Somebody said over here. The real number system, right? So what does the real number system consist of? Real number system consists of positive numbers, negative numbers, rationals, and irrationals, right? All of those things. Any fraction, right? All those decimals that we know about, right? Positive numbers and negative numbers and 0, right? So you guys know what all those are. And so your question right now is like, yeah, dude, time out, back up for a minute. There's other numbers? Like, you're telling me there's other numbers besides, like, 4? Like, I can get, like, you're telling me I can get an answer to this? The answer is yes. And what I do is I introduce something new to you guys. Ready? It's called the imaginary number system. And the imaginary number system only has one thing that you have to know. And if you know this one thing, you can now talk about imaginary numbers. Ready? It's the easiest thing in the world. And it's right in front of you. I equals the square root of negative 1. I is considered to be a number. Now, it is not the I that's in our alphabet. Because what does I equal? The square root of negative 1. With me? I equals the square root of negative 1. Okay? So, this is what we're going to do with it. Hold on one second, and then I'm going to answer. Okay? So here's what I'm going to do. I want to simplify this. And before you walked in this room today, if I put this on your paper and I said simplify it, and you've been paying attention, you would say I can't. And what I'm going to tell you is now you can. And here's what you're going to do. What number that is negative can I take out of any negative number? Negative 1. So do you guys agree that I could change this to be radical 9 and radical negative 1. Do you agree that those two radicals would multiply to give you radical negative 9? Yes, because do you agree that the two things underneath Yes, because what I did is I rewrote this as two radicals. These two radicals will multiply to give you that, right? Now you're going to see why I did it right now. What's the square root of 9? 3. And what did I tell you guys the square root of negative 1 equals? I. So guess what? This is equal to 3i. So the only difference between this answer and this answer is that the square root of 9 is what? 3. So if I throw a negative in front of there, I can answer it the exact same way, except just do a what? An I at the end. So if I asked you guys to simplify the square root of negative 100, what would you make that? You would make that the square root of 100 times the square root of negative 1. What is the square root of 100? 10. What is the square root of negative 1? So it's equal to 10i. Seems really, really similar to our number system, doesn't it? Except one additional fact gets thrown in. Okay. Now you see this one and immediately you're gonna freak a little bit, but I want to get rid of the negative, right? Because I want it to look like that. Guys, what can I change radical 18 to be? What is there a perfect square that fits into that? 9 does. How many times? Twice. And what is the square root of negative 1 the same as? Square root of 9? 3. Square root of 2 remains the square root of 2, right? Can't simplify it any further. Now here's a funny thing about imaginary numbers. Imaginary numbers are usually written prior to radicals. So if you're going to write this answer, you're going to write it as 3i radical 2. Guys, would you agree that imaginary numbers are pretty easy to deal with? You just treat them like they're regular numbers, and then you throw an I at the end, right? That's all you're doing. All right, solve each of the following and give me your answer in simplest radical form. It says solve the quadratic. So guys, what's wrong with this quadratic? It's not equal to 0, so I'm going to add the 12. And I get 5x squared plus 20 equals 0. Now, a couple of things about this. First of all, is there an x term? No, there's no x term, right? If there's no x term, we can use that technique that we talked about on the first page, which is to what? Move this 20 over, divide by 5, and then take the square root, right? So I can actually do that here. So I could have actually moved the 8 over instead, but that's okay. Divide by 5. That gives me x squared equals negative 4. And now I got to take the what? Square root of both sides, right? So when I take the square root of both sides, remember, because it's an equation, we get two answers. We get positive and negative, the square root of negative 4. And I'm already here in the peanut gallery sort of saying, okay, yep, square root of negative 4 is the same as 2i. So what is my answer? It's positive and negative 2i. If we look at example B, are there any x terms? No, there's only an x squared in numbers, right? Which means we can use the square root method, which is to move the 10 over. Divide by 2. And take the square root. Now again, when it's an equation, we have to consider both what? Positive and negative. So I know that I have positive and negative, radical, negative 13. Now this is where people get a little nervous because this is not a perfect square, right? It's not a perfect square. But what can I always take out of a negative radical? Negative 1. And what's radical negative 1 the same as? I. So this answer is the same as positive and negative I radical 13. And again, this is where, like, you know, if you're not really paying attention, it's like, what? Where the hell did I come from, right? Again, where did the I come from? It came from the fact that there was a negative inside the radical, and when I take it out, it's gone. Why doesn't this radical 13 break down? Because there's no perfect square that can divide into it, right? Does 9 divide into 13 evenly? No. Does 4 divide into it evenly? No, and we're out of numbers, right? Okay? So I can't break that down any further. Guys, this opens up a whole new world. All right, so now we get to something like this. 5i times 6i. Well, guess what? i's work very similar to the way our number system works. So what am I going to do? Well, I'm going to do 5 times 6, and I'm going to do I times I. What does that give me? That gives me 30i squared. Is that one of my choices, though? No. So let's talk about what I squared is. What is I squared? It's radical negative 1 times radical negative 1, correct? It's radical negative 1 times radical negative 1. And what do I do when I have two radicals that I want to multiply together? I just multiply the things that are what? Underneath them. So this is the same as radical negative 1 times negative 1, which is the same as positive 1. What's the square root of positive 1? 1. So this is the same as 30 Oh, hang on a minute. Hang on a minute. I messed that up. Let's ignore what I just said. Erase that. My fault. Cross those last two out. Guys, what is any radical times itself? Whatever is underneath it, right? So radical I times radical, so radical negative 1 times radical negative 1 is the same as negative 1. Thank you. Because what's radical 5 times radical 5? Somebody said it? 5. What's radical 9 times radical 9? 9. What's radical pi times radical pi? Pi. So what's radical negative 1 times radical negative 1? Negative 1. So this is 30 times negative 1, which is negative 30. Now, don't let that problem make you too nervous, because were that to show up on an exam, what Jaden's going to do is this. Jaden's going to say, I want to do 5i times 6i. So he's going to go to this, and he's going to do this. Ready? 5i times 6i, enter. Uh-oh. Variables not defined. Here's the reason why. I is a special math number. Do you guys agree with that? We're getting the sense that I is an important number in math, right? Okay. What other weird thing is kind of important in math that doesn't look like a number? Pi. If I asked you guys to find pi in the calculator, where would you go? You'd go down here, right? You would hit that. And look what's right next to pi. An I. Right? So I want to do 5i times 6i, and I get negative 30. So your calculator will calculate imaginary numbers for you. Check it out. I squared. I squared gives me negative 1. So there you see it, right? So we just did this one, guys. We just said I to the first is 1. I squared is, we said negative 1, right? So now my question is this, guys. What is, by the way, I'm not going to calculate any more of these. Oh, I'm sorry. What was your question? Oh. I'm sorry. I cubed. Guys, how am I going to get I cubed? Well, isn't it true that I cubed would be the same as I times I squared? Wouldn't I times I squared be the same as I cubed? So what is I times negative 1? Negative I. Is it confusing? Okay, so you're going to do this next one. Ready? I to the fourth. Do you agree that I to the fourth would be the same as I squared times I squared? What's negative 1 times negative 1? Positive 1. Seriously. Now, somebody else might look at this and say, well, hang on, Picardo, why didn't you do I times I cubed to get I to the fourth? Well, what's I times I cubed? It's negative I squared, right? Well, what's negative I squared the same as? It's the same as negative this, which is equal to 1. So you can do it either way. What's I to the fifth the same as? Isn't I to the fifth the same as I squared times I cubed? So what's negative 1 times negative I? I. How about I to the sixth? How can I get I to the sixth? Oops. How can I get I to the sixth? Well, to get I to the sixth, I could do I squared times I to the fourth, right? What's I squared times I to the fourth? Negative 1. Well, how did I get I to the seventh? Well, I could do I cubed times I to the fourth, right? What's negative I times 1? Negative I. And how do I get I to the eighth? Well, to get I to the eighth, couldn't I do I to the fourth times I to the fourth? Okay, well, I to the third is just going to be what? I times negative 1. Yes. Yeah. Yeah. Now, guys, all of this that I just showed you right here, guess what? Totally 100% don't care if you get it. You know why? Check it out. Here is I to the first. Here is I to the second. Here is I to the third. To the fourth. To the fifth. Oops, I messed that one up. That was not I to the fourth. That was what? I times 4, right? Yeah. And you get the idea, right? So guys, any of that work you can simply do in the calculator, can't you? So if I asked you guys to do these, would you really have any problem? Now, this says without your calculator. So I'm going to show you guys a cool little trick that you can use. Because if you go back up here, what do you notice about this row, this row, this row, and this row? They're the same. So in fact, you guys agree that I to the 9th would be next, right? Well, how do I get I to the 9th? Couldn't I do I cubed and I to the 6th? And what's negative I times negative 1? Positive I. And so guess what? This is still the same. So what I'm going to show you guys, oh, by the way, so if I said I to the 12, do you really have to do anything right now? What's I to the 12 going to be the same as? I to the 4th and I to the 8th, right? So it's also 1. And this is also equal to negative I, and this is also equal to negative 1, right? So those columns, right? Those columns all are the same. Again, Blake, does it matter if we really know that? Really, at the end of the day, does it matter? No, because we use the calculator for it, right? But this problem, for some reason, wants me to do this without a calculator, okay? So what I'm going to show you guys is how do you evaluate to the 38th power this way? Well, it's actually kind of easy. See how this kind of just loops around and it just keeps looping around and doing the same thing over and over and over again? Well, here's I squared, here's I cubed, here's I to the 4th, right? So the way I like to think about these is it just kind of keeps going around and around and around, right? They just keep going around and around and around. In other words, this is the 1st power, 2nd power, 3rd power, 4th power. This would be the same as the 5th power, right? And then the 6th and the 7th, and that's the same as the 8th, right? And then the 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38. So I to the 38 is the same as I squared. That's the way you would do it. That's the way you would do it. Same as I squared. And what did we say that I squared is equal to? Negative 1. Now again, Trinity's question was, well, do I have to do all that? No, I mean, it's a way you could do it if you didn't have a calculator, but of course you do, right? So I to the 38th, just to make sure that I didn't mess it up, I raised to the 38th power is equal to negative 1, right? There's no work you can show. There's no work you can show. The only thing you could say is this, right? So if I said, guys, let's find I to the 21st, you would go to your little clock here. I call this clock counting. So I got to get to the 21st, right? So I'm at 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So I to the 21st is the same as I to the 1st. All right, I'll save you guys the trouble here. We're not going to do 83. We could count 83 times, but I to the 83 is negative I, and I to the 40, oops, I keep doing that, and I raised to the 40 is 1. That okay? And then lastly, which of the following is equivalent to 5i to the 16 plus 3i to the 23 plus I to the 26? I wonder if I could just type that in the calculator. 5i to the 16 plus 3i to the 23rd plus I to the 26. Look at that. 4 minus 3i. It will literally do that for you. So, Jaylani, when you walk out of here today, if there is one thing and only one thing that you have learned, it is what? I equals the square root of -1. And so we have a whole new world of numbers that we can explore that involve negative radicals. Told you guys it was not going to be that bad. Did I lie?